Grace and peace be multiplied unto you. I welcome you to today's lesson in science on the topic transmission of heat energy. So, in this topic, we will learn how heat energy is transferred from one place to the other. So, let's look at the meaning of heat. Heat is a form of energy that is transferred from a region of higher temperature to one of lower temperature. So let's look at the meaning of temperature too. So in order to know what heat is, you need to know what temperature is. You need to know what temperature is. So temperature is the degree of hotness or coldness a body is. So that's the meaning of temperature. Temperature simply is the degree of hotness or cold a body is. So heat is a form of energy that is transferred from a region of higher temperature. So when we say higher temperature, we usually mean something of that is hot, but that is not really the understanding. One, because we are comparing two things. If something is very cold and another thing is less cold, these two, one will be hotter than the other, even though they are all cold, because one is very cold and the other is less cold. Okay, so heat simply is a transfer of energy from a region of higher temperature. So once the temperature is known, so it doesn't matter whether the thing is hot or cold, because it's two things. They can both be cold, and one will be very cold and the other will be less cold, or they can both be very hot and one will be very hot and the other will be less hot. So that is how heat transfer occurs. So heat as a form of energy. The sun is the primary source of heat energy. Most of the sun's heat is radiated back into space, and only a small amount of it reaches the earth to keep it warm. So the heat that comes from the sun is not all the heat that the sun produces. It's just a little one that reaches the earth. So let's look at the heat transfer methods. We have conduction, convection, radiation. So we have three heat transfer methods. They are conduction, convection, and radiation. So let's look at conduction first. Conduction is the transfer of heat through a material from the hot to the cold region, hot to the cold region, without any visible movement or flow of the material. Let me take it again. So conduction is the transfer of heat through a material from the hot to the cold regions without any visible movement or flow of the material. So sometimes you put a pot on fire, and then you realize that there is a direct flame to the pot. Or also, yeah, so let's take with that example. You put a pot on fire, realize that there is a flow of heat from maybe the bottom of the pot to the top of the pot. Or there is, let's say, a part of a let me draw an example. You have a rod, and then this part is being heated with fire. You realize that over time this part will also get hot. Okay, and that is conduction. There's a flow of heat from one point which is very hot to the other point which is not very hot, which is less hot. Okay, so the flow of heat will go this way. Alright, so that is conduction. Let's look at examples. Conduction from hot soup to a spoon. So if you have hot soup and then you put a spoon, you dip a spoon inside, realize that the spoon becomes hot as well. Okay, let's look at another example. Conduction along a metal rod being held in a flame. So you realize that with this rod in the flame, that side will get hotter first, but at the end of the day, the side you are holding will also get hot. That is conduction. Conduction from a frying pan to a cooking egg. So the heat from the frying pan is transferred to the egg, and that is conduction. Okay. Heat conductors and insulators. So there are materials that are very good conductors and others that are very poor conductors. When we say something is a conductor, simply means that it allows, heat and electricity to pass through. So there are some materials that are very good conductors and there are some materials that are very bad conductors of heat and electricity. So heat insulators are not very good conductors of heat. They conduct heat slowly. So materials that are not good conductors of heat are called insulators. Materials that are not good conductors of heat are called insulators. And those that are good conductors of heat are called conductors, heat conductors. So at the other end, heat conductors conduct heat faster and are good conductors of heat. Let's look at examples of conductors. So examples of conductors, we have silver, we have copper, we have aluminium, we have iron. These are all metals. And then examples of insulators, we have vacuum, we have air, we have cork, we have glass and wood. So wood is also an insulator, and rubber as well. Convection. Convection is the transfer of heat from one part of a fluid to another by the movement of the fluid itself. So when it comes to convection, we are talking about heat transfer in a fluid. So it could be water, it could be any liquid substance, but then the heat will be transferred within the fluid. So the fluid is a substance which can flow. Anything that can flow is a fluid. So liquid and gases are fluids. So heat transfer of liquids is convection. Let's look at example. Convection occurring in water inside a pot on a stove. So when there is a water on the stove, you realize that the water in the beginning is what, it's not very hot, but at a point in time you realize that below it, it starts, the fluid starts moving, and boiling occurs. The movement, what happens is that the hot fluids move to the upper part and the less hot comes to the lower part, and they are heated and then they go up and up, and so it moves like in a flow. That's how it goes. Let's look at another example. Convection in the atmosphere during the day. Warmer air rise off the land and cooler air sinking over the water. So during the day too, you realize that the warm air below or on the surface of the ground move up and cold air comes down. That is how come rain even falls. So convection in the atmosphere during the day, warmer air rise off the land and then cool air sinks down. Let's look at another convection in the atmosphere during the night, warmer air rises off the water and the cooler air sinks over the land. Okay, so convection simply is the transfer of heat from one part of a fluid to another by the movement of the fluid itself. And fluids are liquids and gases. Okay. Convection. So consider this: when you look at the road in the summertime, or the hot day, you may notice that the air above the road looks blurry. This is convection taking place as the hot air directly over the road absorbs the heat from the road and rises. Although the explanation can be quite complex, convection can help explain why mirages are seen in the desert. So sometimes when you see a blurry look, when during sunny days and you're standing far up, you can see a blurry look in the atmosphere, and this is a sign of convection happening because warmer air is rising. Let's look at radiation. Radiation transfer is the transfer of heat in the form of electromagnetic waves. So the key words are electromagnetic waves, which do not need a medium. So in radiation, you don't need any fluid, you don't need any material. It is through waves, and waves cannot be seen with the naked eye. To reduce the loss or gain of heat by radiation, an object should have a shiny, silvery, and smooth surface. To increase the loss or gain of heat by radiation, an object should have a dull black or rough surface. So for an object to absorb much heat through radiation, the object needs to be shi- shiny, silvery, and smooth. And for the object to lose heat, the object needs to be dark, black, or have a rough surface. So if conduction deals with solid and convection deals with liquids, how does heat arrive to the earth from the sun? There is very little matter in between the earth and the sun, and that is space or vacuum. So it is through this space that radiation occurs, where the waves of the sun moves to the earth, travels to the earth, and the earth gets warm, and we are able to feel the heat from the sun. Heat can travel in waves without a medium, a liquid, solid, or gas. Radiation is a term that describes heat movements without a medium of matter. So let's look at an example of a material that uses both conduction, radiation, and convection. So a vacuum flux keeps things close to their original temperature by reducing the transfer of heat between the flux and its surrounding. Heat transfer by conduction, convection, and radiation is reduced by the special feature of this flux. So a vacuum flux is one that uses the idea of convection, conduction, and radiation to make sure that water or any liquid poured in it's able to stay in it's able to have the same amount of temperature, almost the same amount of temperature for quite a long time, because of the idea of conduction, convection, and radiation. Okay, so this ends our topic on transmission of heat, and I hope this topic is well understood. I have given some exercises, and I hope this video will help you answer them. Until we meet again, enjoy your day. Bye bye.